Okay, to start off, we are going with sets of numbers and the real number line. So in the book, if you had a book, is 9.1, just so that we can get everything in order. I'm going to reference that it's section 9.1 because in the old version of the book, when there was a book, that was the section. So just for clarity, I am going to use that, but don't worry, there really is no book. So we've got the set of real numbers. The real numbers encompass 0, all positive, and all negative numbers. The set of real numbers can be represented graphically on a horizontal number line with a point labeled as 0. Because remember, we're not in any kind of 2-variable, 3-variable plane. Let me turn my phone on silent. Sorry about that. So it's just numbers, just a straight number line. So at the beginning of the class, we are dealing with just the number line. We don't add in the y-axis until chapter 2. When is that? I'm not sure when, but not till later. So no worries. But here's your number line. You've got 0 here in the center of this line. To the left are negative numbers. To the right are positive numbers. So moving to the right, the numbers get greater numerically. And as we move to the left, the numbers get technically smaller and smaller because -2 is less than -1. Right? We're getting more negative. So if I give you this set of numbers, so first off, whenever you see something in these braces like this represents what we call technically a set. It's just the red flags the kind of signposts that say, here, inside of me, these are the numbers you need to pay attention to. So I'm going to call it a set because that's technically what it is, so that we're all on the same page jargon-wise. So here's our number line. I've got 2. So I'm just going to put a little dot on 2. -5, 1/6. Okay, so that's 1/6. So that means if we take the 1 and we break it up into 6. So there's thirds. Here's 6. Right? So 1, 2, 3, 4, 5, 6. Yeah. This is very specific, but you can just ballpark it on your paper. Basically, you just want to be a teeny tiny bit to the right of 0. -1.8. So here's -1. Remember, -1.8 is almost -2. So I'm just going to call it right there. I'm not asking you to be super specific, just a general area so that you know where you're plotting. All right, so now -5/2. We know we're on the left-hand side of the number line. So -5/2 means that it is 2.5, right? Because if I count by 2s, that's 2, 4, 6. 6 is greater than 5, so I know that there's 2 in there because 4 divided by 2 is 2. So -5/2 is the same thing as the mixed fraction, which we're not really going to use, but just to get the point across, is 2.5, right? So this is it's technically called the improper fraction, but it's more proper than the mixed fraction. But just so that we can see more clearly where we're going to point this, maybe the mixed fraction is better. Also, if you were to slap that into your calculator, you would see that it's -2.5. So I'm going to go right here, halfway between -2 and 3, -3. And then last but not least, 3.1. So I'm going to go 3, and then the 0.1 just barely to the right of it. Okay. So plotting on a number line. Again, not asking you to be super, super specific in your drawing, just needs to be in the general area. A set is a well-defined collection of elements, right? Like I said up here. Several sets of numbers are used extensively in algebra and are subsets or part of the set of the real numbers. Before I get too into this, there's real numbers and then there are complex numbers. with the complex numbers also following with the imaginary numbers. We'll talk about that later on when we are in the college algebra section of things or topics of things. But just for now, so there's like what I thought everything was a real number. There are such things called imaginary numbers. We'll learn about them, but don't fret about that now. We'll get there when we get there. Okay, so subsets of the real numbers. We've got natural numbers, whole numbers, and integers. When I say numbers, you probably are more thinking of a whole number, but the natural numbers is really the way of which if I were to enumerate or to call every student out or to like list the number of items that are on my desk, you count them out 1, 2, 3, 4, 5, right? That's the natural way to list things. So hence natural numbers. One thing in math that is really super cool that the old people way back in the day did a solid favor is they called it like they saw it. Truly, in math, I get it. The math is hard enough. Don't have to tell me. I am very much aware. But they called it like they saw it. So they didn't get really imaginative when they started labeling these things. So over and over and over again throughout the course, I'm going to remind you to use that as a tool to yourself. Whatever things are labeled, whatever they're called, whatever the name is, it either says what it is, does, defined, or I'm missing something. What it is, what it does, what it finds. Yeah, okay, I'll call it good there. So again, natural numbers, this is the natural way in which we would list something off. So whole numbers, now you're adding in basically 0. That's it. So you're adding in 0 to the natural numbers and you get whole numbers. Again, a whole number is what you think of probably when you think of numbers. No decimals, no fractions, no funny business. Just 0, 1, 2, 3, blah, 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 blah. Now, integers is what you get when you add in the negative numbers. So an integer is something I want you to highlight, really know this word, integer, okay? I'm going to refer to integers over and over and over and over again in the class. So if you know what an integer is, just know that I'm talking about basically the whole numbers plus the negative numbers. So again, here you've got no decimals, no fractions, no funny business. It's just the negative numbers plus 0 plus positive.